Welcome everyone. In this video, we're going to be working out this sample final exam. This is for Math 195, which is pre-calculus sample final. Make sure to use no electronic devices as you're working out these questions. Also try to do the questions first before you continue watching the video. And thank you for being here. I will also provide a PDF version of the test in the description box for you to work them out first if you don't have access to the copy. All right, so let's get into it. So let's name this file solutions to this test. For number one, we're going to find the center and the radius of the circle given by this equation. All right, so we're going to have to complete the square. Let's go ahead and do that. So I'll rearrange the terms. I will put the x next to each other and the y terms next to each other. And the constant, I'm going to move it to the other side. So we will have x squared plus 1/2 x, leave a space, plus then the y terms. We have y squared plus 2y, leave a space, equals to 1/16. I'm going to subtract it, so it'll be negative 1/16 to the right-hand side. All right, once you have done that, use the formula for completing the square. So for the x variable, we're going to take half of 1/2. That's 1/4. You square it, you'll get 1/16. So I will add 1/16 to this side. I also add 1/16 to the right-hand side to keep it balanced. And once you do that, your factors for x variable will become x plus b/2. So that's 1/4 all squared. Now, continuing on to the next variable, the y variable, we're going to take half of its b term, which is 2. So that will be 1. When you square 1, you get 1. So I'm going to add 1 to this side and also add 1 to the other side. And then the y variable will factor into y plus b/2. So that will be 1 squared. And this is equal to, and of course, on the right-hand side, as you can see, these will cancel out. So you'll just have equal to 1. So there you have the equation in standard form of a circle. So now we can identify what the center is. The center would be negative 1/4, comma, negative 1. That would be the x and y coordinates. And the radius of the circle would be 1. So there you go. This is the information we were after for this problem. All right, moving on to the next problem. We're going to be solving this equation. T squared minus 60 plus 1. Seems like this is not factorable. So we're just going to go ahead and use the quadratic formula. So we know the quadratic formula is x equals, since our variable is t, I'm going to write t equals negative b plus and minus the square root of b squared minus 4ac, everything over 2a. So a is the coefficient of x squared. So in this case, a is 1, since our x squared is t squared. B is the coefficient of x, the linear term. In this case, it's the coefficient of t, that's negative 6. And c is the constant term, that's 1. Once you have correctly identified them, plug them in. So t is equal to negative 6, since our b is negative 6. Plus and minus the square root of b squared. So negative 6 squared, that's 36, minus 4 times a times c, all over 2 times a. Plugging it in very carefully. Now, if you simplify this, you will have 6 plus or minus square root of 36 minus 4. That would give you 32. Everything divided by 2, so I'm going to split it up into 2 fractions. Be very careful when you do that, because this denominator is influencing everything that's on the numerator. Okay, continuing on. So I can simplify this further. This is 6/2, that's 3, plus or minus. Square root of 32, you can simplify it this way. So this is 16 times 2, and then 16 will simplify. Square root of 16 is a 4. Square root of 2 doesn't simplify, so that's just 4 square root of 2. So 30 square root of 32, I can replace that with 4 square root of 2. And now I simplify this further. 4/2 simplifies to 2 root 2. So there you have it. Just keeping it consistent, 2 square root of 2. So this is our value for t. We have 2 solutions. Moving on to number 3. For number 3, we want to find all solutions to this equation within this interval, 0 to 2 pi. So we want our solution to this equation. Let's isolate the trig function. secant theta. So we can subtract 4 from both sides first. So we got 2 secant square of theta is equal to 4. I added 4 to both sides. Divide by 2 on both sides, you get secant square theta is equal to 2. Take the square root on both sides, so you'll have secant theta is equal to plus and minus square root of 2. Now remember, plus and minus because you're taking square root of a square expression. Now I'm going to go ahead and rewrite this in terms of cosine, because secant is 1 over cosine. So that means if secant theta is plus and minus square root of 2, that means cosine theta would be the reciprocal of that. So cosine theta would be plus and minus 1 over square root of 2. And if you don't have this version memorized, you can also rationalize this is plus and minus square root of 2 over 2. So we want to know what is theta within this interval that gives us cosine to be square root of 2 over 2, plus and minus. So let's try to draw these in our plane right here. So remember this acronym, ASTC. So we know that cosine is positive in this quadrant and this quadrant. So that's where we're going to get the positive square root of 2 over 2. There are 2 solutions. And then the negative square root of 2 over 2, the angles are going to be lying on these 2 quadrants. So let's do that. So we're going to find solution in every quadrant. There will be 4 solutions. So the first solution, let's call it right here. Let's call this theta 1. So theta 1, it's going to be the reference angle. So cosine of which angle gives us positive square root of 2 over 2, but we know that that's pi over 4. So this theta has to be pi over 4. So that's one of our solution. And using that, we're going to find solution that corresponds to this angle in every quadrant. The second quadrant, we want this angle right here. So this will be theta 2. So let's write it right here. Theta 2 would has to be pi minus the reference angle. So that would be the next angle, which will also correspond to cosine of negative square root of 2 over 2, because cosine is negative in this quadrant. So this theta would be 3 pi over 4. So that's our next solution. Then the next angle will be the one that lies on the third quadrant. So that goes around and terminates right here. So let's call that theta 3. And this angle would be pi plus pi over 4. And that would give us, sorry about the spacing, 5 pi over 4. That's our next angle. And the last angle for this equation, we're going to be again going around and terminating on the fourth quadrant. So perhaps something like this. So you start right here, go all the way around and sorry, that was the wrong drawing. You start right here and you go all the way around, terminates right there. Let's call this theta 4. So theta 4, it's going to be 2 pi minus pi over 4. That would give us 7 pi over 4. So these are our 4 solutions within this interval, which corresponds to positive square root of 2 over 2 for cosine and negative square root of 2 over 2 for cosine. So you get 4 solutions. So our solution, let's explicitly write it out. So our solution is going to be pi over 4. Then we have 3 pi over 4. Then we have 5 pi over 4. And then we have 7 pi over 4. So these are the 4 solutions for this particular equation. All right, moving on to the next problem. So for this problem, we're going to be combining this algebraic expression, so using common denominator. So first thing you want to do, make sure everything is factor. So first and second fractions are good, but the last fraction, you might want to factor that. So we rewrite 2 over x plus 3 over x minus 1 minus 4 over x times x minus 1. So that's how I factor the last fraction. So the LCD, or the least common denominator for this, would be x times x minus 1. All right, so we give each fraction what they're missing. So for the first one, I will multiply this by x minus 1 over x minus 1. For the second fraction, I'm going to go ahead and multiply that with what it's missing, which is x. So multiply this with x over x. Don't forget the parentheses. And for the last fraction, it's not missing anything, so there's no need to modify. All right, so let's combine the numerators now. So we have 2 times x minus 1. That will be 2x minus 2 plus 3 times x. That's 3x minus 4 all over x times x minus 1. We're going to combine like terms. So this one and this one, they're like terms. So that would give us 5x, and the negative 2 and negative 4, they're like terms. So that will give us negative 6 all over x times x minus 1. So this is my simplified answer for this fraction. If you would like, you can distribute the denominator, but that's not really necessary. Number 5, we're going to be solving this logarithmic equation. So first thing you want to do is combine this into a single logarithm. So I'm going to go ahead and move this piece to the left-hand side by adding it. So we have log of x plus log of x minus 3 equals to 1. And then by using the laws of logarithm, since I see a plus between logarithms, I combine them. This is log of x times x minus 3 is equal to 1. Now remember, this logarithm is using base 10 since it's not written for us. So every time base is omitted, it means it's base 10. So now if I translate this into exponential form, this would be 10 to the power of 1 equals x times x minus 3. So now it becomes a nice algebraic equation that we all know how to solve. This is 10 is equal to x squared minus 3x. Move everything to one side. So we have 0 is equal to x squared minus 3x minus 10. And now we try to factor this. I'm going to try to make this a bit smaller so I can have a little bit more space to write on. All right, so I'll factor this. So we got, this can be factored into x minus 5 and x minus 2. That will work. Plus 2. Yeah, this will work. All right, so that means our x values are positive 5 and negative 2. Now, if you try to check your answer, for example, for logarithms, you should always check. So if I plug it into the original, and I'm trying to plugging it into for each x in the original equation, when you plug in 5, this is log of 5, that's a positive value. This is log of 5 minus 3, that's 2. So log of 2, positive value, checks. So 5 is good. Now, what about if you plug in negative 2? So when you plug in negative 2 in here, in the logarithm, this is a problem. Logarithms, the domain for it is 0 to infinity, not including 0. So when you plug in negative values, it doesn't make sense. So therefore, this solution is going to be omitted. So our only solution to this equation would be x equals 5. That will be the only solution. All right, moving on to the next problem. So we're looking at tangent inverse of negative square root 3 over 3. So let's let theta be equal to tangent inverse of negative square root 3 over 3. So if I apply tangent on both sides to get rid of the inverse, we have tangent theta is equal to negative square root 3 over 3. And we want to know what is the angle. So the tangent is negative square root 3 over 3. So we know that this theta has to be in the interval negative pi over 2 to pi over 2, because that's the range for tangent inverse, because the domain of tangent, restricted domain for tangent is negative pi over 2 to pi over 2. That's why we define it to be 1 to 1. So now since it's a negative exact value, we know our solution is not going to be here. So we rule on that angle because that will give us positive square root 3 over 3. we want the angle that goes this way. So the negatives, because this is the boundary. This is negative pi over 2 to pi over 2 for tangent inverse. So we know this angle, this is pi over 6, because tangent of pi over 6 is positive square root of 3 over 3. That means this has to be the negative pi over 6. That will give you the negative square root of 3 over 3. So also remember, your solution cannot be here because they're not in our restricted domain for tangent. So now our theta is negative pi over 6. That's the answer to this problem. All right, next one, cosine of negative 7 pi over 6. Now, since cosine is an even function, we don't need to draw negative 7 pi over 6. We can just simply apply the property. This is cosine of 7 pi over 6. So note that cosine of negative 7 pi over 6 is equal to cosine of positive 7 pi over 6. And the reason for that is because cosine is an even function. So now I can go ahead and find the reference angle and figure out its exact value. So let's rewrite, or if you like, you can convert to degrees. So 7 pi over 6, that can be written as pi plus pi over 6. That's 7 pi over 6. So if you draw it, this is pi, and then pi over 6 is just a little bit more. So the reference angle is right here, this little bit more that we want. Or you can do 7 pi over 6 minus pi. So you'll get pi over 6. That is our reference angle. So let's go ahead and now fill this in. So I can rewrite this as plus and minus cosine of its reference angle. Now, is it positive or negative? Well, we use this acronym, ASTC. So only tangent is positive on the third quadrant. So cosine will get a negative sign. And we know the reference angle is pi over 6. So I'm just going to replace that right here and we're ready to go. All right, now from memory, we know cosine of pi over 6. This will give us the exact value of square root of 3 over 2. So this is negative square root of 3 over 2. So that's the exact value of this angle. Number 8, we're going to find the average rate of change of this specific function between 5 to 10. So the first value is always A, the second value is always B. So we know the formula is f of B minus f of A all over B minus A. This is the average rate of change. So let's find these values and then we plug them in. So for f of A, that's going to be f of 5. So plug in 5 into your function. We do 5 cubed minus 5 times 5 squared. That's 0. And then f of B, that's going to be f of 10. That would be 10 cubed minus 5 times 10 squared. So this would give you 1,000 minus 10 squared, that's 100 times 5, that's 500. So this is 500. All right, so we got the values for f of A and f of B. Let's plug them in here. So f of B, we got that to be 500. F of A, we got that to be 0. Divided by B, that's 10 minus A. That's 5. All right, so if you simplify this, you will have 500 over 5, and that would give you 100. There you have it. This is our average rate of change. All right, for number 9, here we have an application of the exponential function. The initial size of a bacteria culture is 1,000. That's the initial size. So I'm going to call that PO. That's 1,000. After 1 hour, the bacteria count is 4,000. So P of 1 is 4,000. After how many hours will the bacteria population reach this much? So we want to know what is T so that the amount at that time is 7,000. That's what we want. All right, so let's hold on to that thought. So using these two pieces, we can figure out the rate. So let's find what is R. So I'm going to go ahead and use the formula. The amount at any given time t is equal to the initial amount times e to the power of RT. So we need the amount after 1 hour. So this is 4,000 is equal to, we know the initial amount, so that's 1,000 e to the r, we don't know, time 1. So we know when t is 1, this is the amount. That's what it grows to. Let's simplify, solve for r. Divide by 1,000, so you have 4 is equal to e to the r, and you take natural log on both sides. So you'll have r is equal to ln of 4. So that is the rate. Now let's write down the model and then we can answer the problem. So our P of t is equal to 1,000 times e to the r, that's ln of 4, times t. Now here you can simplify this by using the laws of logarithm. Here ln and e are free to cancel. So I can rewrite this as 1,000 times 4 to the power of t. So that's the model we're going to use to answer the problem. So we want to know what is time, so the amount reaches 7,000. So we set our P of t to 7,000 and solve for t. So we have 7,000 is equal to 1,000 times 4 to the power of t. Divide by 1,000 on both sides. So you'll have 7 is equal to 4 to the power of t. Now you can take natural log on both sides. So you have ln of 7 is equal to ln of 4 to the power of t. Now, using the laws of logarithm, again, the t can drop down as a base. So you can multiply it, and then you can divide by ln of 4. So the time it takes for the amount to reach 7,000 is ln of 7 divided by ln of 4. So that will be our answer for this problem. Sorry, it's a little crowded, but I will just push this up here so you can see it better. So there you have it. This is the final work. All right, for number 10, we're going to be solving this equation. This is an exponential equation, so we are going to take natural log on both sides since there's no way to write both sides using same base. So let's take natural log on both sides. So we have ln of e to the power of 3 minus 5x equals ln of 16. Now here again, I can bring down the exponent by using laws of logarithms, and we also know ln of e is 1. So the left-hand side is just 3 minus 5x, and this is equal to ln of 16. And then now you just isolate x. So I can add 5x to both sides. So you have 3 is equal to ln of 16 plus 5x, subtract ln of 16. So you'll have 3 minus ln of 16 is equal to 5x. Now we divide by 5. So x is equal to 3 minus ln of 16 divided by 5. And there you have it. This is the answer for this equation. For number 11, we're going to solve this nonlinear inequality. First thing you want to do is move everything to one side. Let's move it to the left side. Subtract 3. So you have x over x plus 1 minus 3 is greater than 0. And now I want to write both under same base. I'm sorry, under same denominator. So I'll multiply this by x plus 1 over x plus 1. So that would give us x minus 3x minus 3 over x plus 1. I distributed the negative as I combined it with 3. And this is greater than 0. Now combine the numerator a little bit more. You get negative 2x minus 3 over x plus 1 greater than 0. Now let's find when is this inequality equals to 0. So the top equals to 0. So the top 0, it's going to be negative 2x minus 3 equals to 0. So you'll have 3 over negative 2 is equal to x. So that's when this is equals to 0. And then the bottom 0, it's going to be when the bottom is 0. So x plus 1 equals to 0. That would give you x equals negative 1. So these are the numbers we're going to plot on the real line and test between them. All right, so now we're going to plot them on the real line and see what we get. So here's our real line. And let's suppose this is, so negative 3 over 2, that's about negative 1.5. So this is negative 3 over 2. Let's say negative 1 is right here and so on. Now we pick test values. So in this interval, we can test -3, and then in between we can test -1.1, and in the last interval we can test 0. All right, so let's keep them and plug them. We're gonna plug them in here. This is the simpler one to test. So if I plug in -3 into that expression, this right here, we get -2 times -3 minus 3 over -3 plus 1. So on the numerator, we're going to get a positive value, on the negative value, so overall it's negative. So in this interval, it's negative. And similarly, if we plug in the next point, -1.1 in place of x, so this is -1.1, -1.1. So on the numerator, we're going to get a negative value. And on the denominator, we're also going to get a negative value. So that will give us overall a positive result. And the last one, if you plug in 0, you're going to get negative. So you can check that for yourself. So we want our inequality to be greater than 0, meaning positive interval. So that happens to be only this right here, open-end points, because the inequality is the strict inequality. So our solution to this inequality is open -3/2 all the way to -1. So that will be the solution to this inequality. All right, for the next problem, we're going to be finding this exact value. So ignore the typo right here. This is just, it should be just h of x is not 0. So I'm going to erase that. All right, so now we figure out each pieces and then plug them into our function. We have f of a, so plug in a into your function. F of a, it's going to be 3 times a squared minus 1. That's f of a. F of a plus h, that's going to be 3 times a plus h squared minus 1. And then if you simplify this, so this you can expand and distribute the 3. So you'll have 3 times a squared plus 2ah plus h squared minus 1. Distribute the 3. So that would give you 3a squared plus 6ah plus 3h squared minus 1. And now we plug them into our difference quotient formula. So we want to evaluate f of a plus h minus f of a all over h. So f of a plus h, that's this right here. So that's what I'm going to replace here. And then f of a is this right here. That's what I'm going to replace here. So let's do this very carefully. So this is equal to 3a squared plus 6ah plus 3h squared minus 1. That's f of a plus h minus, so be careful, put parentheses around f of a. That's 3a squared minus 1 all over h. And now here, distribute this negative. So that would give us -a squared plus 1. And now you'll see a lot of the terms will cancel. For example, this with that, and the -1 with 1. So what we're left with is simply 6ah plus 3h squared over h. Factor out the h from the numerator, so you'll have h times 6a plus 3h all over h. Now here again, I can cancel these. So my final result is 6a plus 3h. So that is our final result for this difference quotient. Number 13, we're going to be finding the inverse formula for this particular function. So first thing you want to do is rewrite f of x is 0y. So let y is replaced with f of x. So then we have y is equal to 1 over x plus 3. And then we interchange them. So then we have now x equals 1 over y plus 3. Now I'm going to solve for y. So multiply both sides by y plus 3. So you'll have x times y plus 3 is equal to 1. Distribute the x, so you have xy plus 3x is equal to 1. Subtract 3x, so you have xy is equal to 1 minus 3x, and divide by x, so you have y is equal to 1 minus 3x divided by x. You can leave it right here, or you can simplify this. This is 1 over x minus 3. So we can write that our inverse formula, it's going to be, the inverse function is going to be 1 over x minus 3. So that would be the formula for the inverse function. Okay, so for number 14, so please ignore this labeling. That's not the answer. That's for 13. So for number 14, we're going to find the range of this parabola. So first thing you want to do is find the vertex. So this is a parabola that's facing down like this. So I want to know how far this goes. It's facing down because of this factor. So I want to know how high does it reach. So because that's where the range will have its maximum, and then it's just gonna, that's the highest value we're going to obtain. So we're going to use the formula for vertex. The x-coordinate is going to be negative b over 2a. So here's your a, this is your b, and constant term is c. So let's plug them in. So we have negative 2a over 2 over negative b over 2a. So that's negative 2 over 2 times a. That's 1/2, also negative. Simplify this. So this is a positive 2 over 2 times negative 1/2. That's negative 1. So this is just negative 2. All right. So this occurs at x equals negative 2. So what's the y value? Plug it into the function. So you'll have f of negative 2. So that would give us negative 1/2 times negative 2 squared minus 2 times negative 2 plus 6. So this would give us negative 1/2 times 4 plus 4 plus 6. So negative 1/2 times 4, that's a negative 2. 4 and 6, that's 10. So 10 minus 2, that will give us 8. So this is 8. So our range, now we know it's going to go from negative infinity, since it's facing down, all the way up to 8, including 8. So that will be the range of this parabola. Now for number 15, we're going to, so this graph will be used for number 15. So we want to know what is the local maximum and local minimum values of this function and the x values at which each occurs. So the maximum is the highest value in an open interval. So the highest value is right here, and the minimum value is right here. So as you can see, our local max, it occurs at 0. So, and the value happens to be, so this is 2. So this point, most likely this is 3. So 0, 3. So it occurs at 0, the value is 3. And local minimum value is this one right here. So that occurs at 1, and the value is negative 1. So we have 1, negative 1. So that will be the local minimum value. All right, for the next problem, we want to evaluate cosine of 5 pi over 2. There are many ways to do this problem. I'm going to try to use the sum of two angles formula. So cosine of 5 pi over 12 is equivalent to cosine of pi over 6 plus pi over 4, because that will give you 5 pi over 12. Then using the formula, so recall that if you have cosine of A plus B, two angles, this is cosine A, cosine B, minus sine A, sine B. So that is the formula I'm going to be using to evaluate this trig expression. So our A is pi over 6 and B is pi over 4. So this is cosine of pi over 6 times cosine of pi over 4 minus sine of pi over 6 times sine of pi over 4. And then we know all of these exact values, so just to write them out. Cosine of pi over 6, square root of 3 over 2. Cosine of pi over 4, square root of 2 over 2, minus sine of pi over 6, that's 1/2. Sine of pi over 4, that's square root of 2 over 2. And then this will simplify to square root of 6 minus square root of 2 over 4. So that'll be the combined simplified answer. This is one way to do it. Another way you can attempt this problem would be to apply the half angle formula. So if you like, you can also apply cosine of 5 pi over 6 divided by 2, and then continue from there by using the half angle formula. You will have to play around with your answer a little bit algebraically to make it look equivalent to the answer I have. All right. For number 17, we're going to find cosine theta given that tangent theta and also our angle is in quadrant 4. So remember, in quadrant 4, cosine is positive. So whatever value we get, we make sure to take the positive value. So let's apply the identity that relates tangent with cosine. Well, I can use this identity, tangent squared theta plus 1 is equal to secant squared theta. And then whatever answer I get, I'll reciprocate because secant is 1 over cosine. Let's plug in the value for tangent theta. This is -4 over 3 squared plus 1 is equal to secant squared theta. For -4 over 3 squared, that's 16 over 9 plus 1 is equal to secant squared theta. Well, we know that 16 over 9 plus 1, if you put them in common denominators, you will have 16 plus 9 over 9, which is 25 over 9 is equal to secant squared theta. And now take the square root on both sides. So you get plus and minus square root of 25 over 9, which simplifies to plus and minus square root of 5 over 3. So that's the value for secant theta. Now, since we're looking for cosine, and since it's in fourth quadrant, we will only take the positive value. And also we're going to reciprocate. So therefore, cosine theta would be the reciprocal of that. So it'll be 3 over 5. So that would be the value for cosine. Again, it's positive because we're on the fourth quadrant. So you take the positive value. Now for number 18, we're going to graph this function and label its vertex and all intercepts. So this is a parabola facing down, and it's shifted 5 units to the left and then up 25 units. So here's how the graph would look like. So this is our XY plane. So we know the usual parabola looks like this. So if you reflect over the x-axis, that's what this will do. It will be facing downward, and then plus 5 inside that shifted 5 units to the left. 25, that means indicating we're going up 25 units. So I'll draw the final sketch. So it'll look something like this. So it's a little bit off scale, but hopefully you can see it. So here's the vertex. This is -5, and let's say this is 25. Now let's find the intercepts. So the vertex is labeled on the graph. This is -5, 25. And I want to find these points. So it looks like it's going to pass through 0, 0, but let's check it anyway. So the x-intercept, we're going to set f of x to 0. So you have 0 equals 25 minus x plus 5 squared. This will give you x plus 5 squared is equal to 25. So you get x plus 5 is equal to plus and minus 5, which gives you x equals 0 and -10. So those are the x-intercepts. So this is 0 right here, and this is -10. There you have it. So that's our sketch for this parabola. Number 19, we're going to find the equation of a line passing through these points. So let's find their slope. So the slope, I'm going to use the formula. Let's call this x1, y1, x2, y2. So our slope is given by the formula y2 minus y1 over x2 minus x1. Plug these in very carefully. We got 0 minus 3 over 10 minus negative 7. So this will give us negative 3 over 17. That's the slope. So I'm going to be using this point to write out the equation. So we have y minus y1 equals m times x minus x1. Plug them in. So we're going to be plugging in the point x1 and y1 and the slope. So we have y minus 3 is equal to negative 3 over 17 x minus 7, my negative 7, so it's plus 7. There you have it. I'm writing the point slope form. You can use the slope intercept form if you like, but this is good enough and it's easier to work with. For the next problem, we're going to be finding all solutions to this equation. So let's go ahead and isolate the radical expression. So subtract 2 from both sides. So we have the square root of 9 minus x is equal to x minus 7. And now we're going to square both sides. So we get 9 minus x is equal to x minus 7 squared. This is equal to 9 minus x. On the right-hand side, we can expand. That will be x squared minus 14x plus 49. And now set it to 0. So you will have, move everything to one side. We're going to set it equal to 0. And maybe we can try to factor it. So I'm going to go ahead and do this. 0 is equal to x squared. Add x to both sides, so that's negative 13x. Minus 9 from both sides, that's positive 40. And now we can try to factor this. So this is going to be x minus 5 and x minus 8. That will do. So our values for x would be 5 and 8. But we have to check. So let's plug these into the original. So again, for radical equations, you want to make sure your answer makes sense. So always do check. So if x equals 5, you got 2 plus square root of 9 minus 5. We want to know if that's equal to 5 minus 5. Well, this is not going to be true. You'll see that on the right-hand side, we have 0. But on the left-hand side, we have a real value other than 0. For this next one, x equals 8. We have 2 plus square root of 9 minus 8. Is that equal to 8 minus 5? Let's see. So we got 2 plus 1. That's 3. Is that equal to 8 minus 5? Yes, 3. Checked. All right. So our solution is only x equals 8. This will be the only solution. All right. So I hope you're getting most of the questions right, but let's continue on. We've got a few more to do. So we want to find log base 2 of 1 over 64, turn it into an equation. So I'm going to say log base 2 of 1 over 64 is equal to x. So then this is equivalent to 2 to the x is equal to 1 over 64. Now 64 can be written as power of 2. So this is really 1 over 2 to the 6th power. And then I can bring that on the numerator. So we really have 2 to the x equals 2 to the negative 6. And now the only way this equation holds if the exponents are equal. So x has to be negative 6. So log base 2 of 1 over 64 is negative 6. All right, number 22, we're going to sketch this exponential function. So again, the base is 2, which is greater than 1. So we're using this right here. So let me scale it this way. So 2 to the x looks like this. So that's 2 to the x. We have 2 transformations to apply. So this transformation is going to go down 2 units. And then this transformation is going to go to the right 2 units. So we're going to shift our graph right and then down 2. So we know that this point is 1 and it has the horizontal asymptote y equals 0. So let's move down 2 units. Now it doesn't matter which order you perform them, you'll get the same destination anyway. So move 2 units down. So 1, 2. So my new horizontal asymptote, it's going to be right here. So from 0, I'm going to go 2 units down. So that's -1, -2 right here. This is my new horizontal asymptote. And then the graph also moves down 2 units. So you know it's going to be somewhere right here. And then we're going to go 2 units to the right. So my final sketch would be right here. So 1, 2. So then I'm going to preserve the shape. So it will look something like this. So that is your final sketch. This point of transformation is 2, -1. And we should find this intercept as well. So as the y-intercept right here. So the x-intercept, it will be when y is equal to 0. So we have 0 equals 2 to the power of 2 minus x minus 2. Add 2 to both sides. So you'll have 2 is equal to 2 to the power of x minus 2. Now, since both of these have same base on both sides, I can equate their exponents. So I have 1 equals x minus 2. Add 2 to both sides. So x is equal to 3. So this point is actually 3. That's nice. And for the y-intercept, we're going to now set x equal to 0. So we have y equals 2 to the power of 0 minus 2 minus 2. 2 to the power of -2, that's 1 over 4 minus 2. And then you put them in common denominators, you'll have 1 minus 8. That's -7 over 4. So this point right here, this is -7 over 4. A little crowded, but it's there. All right, so there you have it. This is our final sketch. Number 23, we're going to be sketching a logarithmic function. So here is our xy plane. And we know the logarithm of a base greater than 1. It looks like this. And this point right here is 1, 0. And we have our vertical asymptote right here at x equals 0. Now let's apply the transformation. So first we're going to reflect. So that's what this indicates, reflects over the x-axis. And then this means we're shifting to the left 6 units. So let's reflect and then we'll shift. So when you reflect over the x-axis, the shape will just do this. That's how the reflection will look like. And then if you shift it, the asymptote will shift 6 units to the left. So we will have our new asymptote right here, -6. And indicate that using vertical dotted line. And the graph, the one that I drew in dotted, will shift 6 units to the left. So it's going to be right here at -5. And then it will make its shape. So it'll look something like this. There you have it. And let's go ahead and find this intercept, the y-intercept. So the y-intercept will be when x is 0. So f of 0, that is going to be negative log of 0 plus 6, that's just 6. So this point is negative log of 6. You can leave it in logarithmic form since we're not using a calculator in this test. Now let's go ahead and state the domain and range as well. So the domain of this function, it's going to be from the asymptote, so open, -6 all the way to infinity. And the range, it's going to be everything. So be -infinity to infinity. Everything makes sense. So that will be the domain and range. So as you can see, the graph exists right here, very close to the asymptote, and then it's just growing this way. And the range is all real numbers. All right, now moving on to number 24, we're going to sketch this polynomial. Let's find the zeros, but before that, let's factor. So we have f of x is equal to x squared. X squared minus 25 can be factored into x plus 5 times x minus 5. So the zeros of this polynomial are 0, 5, and negative 5. So now you can try to graph them this way. Before that, let's try to write them on the real line. So we have negative 5 here, 0 here, and 5 here. So if you look at the degree of this polynomial, if you add up their powers, 2 and 2, you'll get 4. So it's a 4th degree polynomial. And the leading coefficient is the number in front of the term. So that's 1, positive. So we know the end behavior, it's going to look like that. It's going to be the usual parabolic look going upward on both ends. So we know from this end, it's going to be positive. This end is going to be positive. Now let's use the multiplicity to figure out what goes in between. So negative 5 came from the factor, this one right here. So negative 5 came from this factor. The multiplicity is 1, odd, so it's going to alternate. So this is negative. Now 0 came from the factor, this one right here. It has a multiplicity of 2, even, so the sign do not alternate, so remain negative, negative. And you don't have to test the last one, but if you want, you can. 5 came from the factor, this one. It has multiplicity 1, odd, so it's going to alternate. And we got positive. And now we're ready to put this on our xy plane. So here's our xy plane. Plot the zeros. So we got 0, 0, negative 5, 0, and 5, 0. And we made the graph. So we're going to have a graph coming from above. So I'll just do my best to make it something like that. Goes through this point, make a tiny parabolic shape, staying below, going through. Something like that. Sorry, it's not the best graph, but hopefully you have a better drawing skills to show the graph. Something like that. So this is our graph. All right, now the last part of this test, we're going to be graphing this trig function, tangent. So we know tangent has its period. So this would be pi divided by k. So k is this number right here. This is k, which is pi over 4. So if I plug this in, I can find the period of this transformed graph. This is pi divided by pi over 4. And this will simplify to just 4. That's the period. Now, tangent also has asymptotes. So the k value also affects your asymptotes. So the original graph has asymptotes at every pi over 2 units. So we're going to be finding its asymptotes, the vertical asymptote. So one of them is negative pi over 2 times k. So we need to modify if you have k. This would be negative pi over 2 times pi over 4, because that's our k. And this simplifies to negative 2. And another asymptote will be negative, positive pi over 2 times k. So that will be pi over 2 times pi over 4, which would give you 2. So these are the asymptotes. I'm only going to draw one period. You can extend it more if you would like. So here's our plane. And here is my first asymptote, negative 2. And the next asymptote, we're going to put it on the right side of the plane, positive 2. And then you just preserve the shape. Now, another thing you might want to worry about is this guy right here, negative 2. So the 2 doesn't really do much to the tangent graph. It stretches it, so it makes it skinnier. But the negative will reflect about the x-axis. So the usual tangent goes like that. But since it's reflected, we're going to be going like this. So something like that. Again, be very artistic how you draw these graphs. I am trying to do it in a way so that you can understand it better. So there you have it. This is one period of this graph. You can extend it left and right and draw more periods. So as you can see, the period is this length right here. This will be 2 minus -2. That's 4. And that's what we got right here. All right, so this is it. That's the end of this test. I hope you got the most out of it. Hopefully you're able to check your answers with mine. Please put comments in the description box if you see any typos or if you see any mistakes. I hope I didn't make any, but it's possible. So please leave a comment below. Thanks so much for watching. I will see you all next time. Good luck on the finals.